Module 1, Lesson 12. The title of this lesson is Ratios of Fractions and Their Unit Rates. For tonight's homework, you only have to answer problem set questions 1 through 3. 1, 2, and 3. Feel free to watch this video to help you understand the major concepts and to see if you got the questions right. Question 1. You are getting ready for a family vacation. You decide to download as many movies as possible before leaving for the road trip. If each movie takes 1 2/5 hours to download, and you downloaded 5 1/4 hours, how many movies did you download? Well, I'm working with movies and hours it takes to download. And if I go back, this first piece of information is very important. Each movie means per one. So each movie takes 1 2/5 hours to download. The per one represents the unit rate. In order for me to solve for how many movies did I download, I'm going to set up a proportion. The first piece of information was one movie. One movie, it takes me 1 2/5 hours to download. My other given information is 5 1/4 hours. I'm going to place it here. Since this side I've decided to make the hours of the download, and the other side is going to represent the movies. So we're solving for how many movies did you download. Okay, so X amount of movies, it's a mystery, and now I have a proportion. You could solve it in one of two ways. You can say, okay, well, how did I get from 1 2/5 to 1, or from 1 to 1 2/5, depending on how you want to look at it, or you can cross multiply and divide. For this example, I'm going to go from the 1 2/5 hours, and I'm going to ask myself, how did I get from that to the original one movie? And you're going to divide by 1 2/5. Whatever you do to the numerator, you do to the denominator. Now you may be asking yourself, why did Ms. Benacki decide to go to the left here and not to the right from one movie to 2 2/5 hours? Well, if I go from one movie to 2 2/5 hours like this, then I would have to do the same for the bottom. And if I don't know how many movies I had, I have no idea how to get from a mystery to 5 1/4 hours. Do you understand that? Hopefully that helped. Okay, so I have my information on my proportion. Now I need to do this math here. So watch the direction of the arrow. So 5 1/4 is going towards the X. So 5 1/4 divided by 1 2/5. And you're solving for the amount of movies that you can download. Why don't you pause the video and try to do this math by yourself. Then you can check and see if you got the right solution. If you need help, keep watching the video. Okay, so let's change our mixed numbers to improper fractions. 4 times 5 is 20, plus 1 is 21/4. Bring down the division sign. 1 times 5 is 5, plus 2, 6, 7, over original denominator of 5. Since we are dividing, we have to do keep, change, flip. Keep 21/4, change division to multiplication, and flip 7/5 to 5/7. Do we have any cross factors? Can we simplify? Yes. 7 and 21 share a common factor of 7. 7 divided by 7 is 1. 21 divided by 7 is 3. 5 and 4 only have a common factor of 1. So we can't do anything there. Multiply across. 3 times 5 is 15. 4 times 1 is 4. Simplify. 4 fits into 15 3 times. What's left over? 12, 13, 14, 15. The remainder is 3 over original denominator 4. What were we solving for? Let's see here. 3 3/4. Let's go back, find the X or the variable in your proportion. Movies. You can download 3 3/4 of a movie in that 5 1/4 of an hour. How did you do in that problem? If you got it right, give yourself a little check or a star or a smiley face. And let's move forward. The area of a blackboard, okay, I'm envisioning now a school. The area of a blackboard is 1 1/3 square yards. A poster's area is 8/9 square yards. Find a unit rate. Do you see how they just said find a unit rate? They weren't really specific as to what unit rate. Are we supposed to find the unit rate between the blackboard and the square yards, or should I do from square yards to the blackboard? It wasn't specific enough. So that's something to keep in mind. It says find a unit rate and explain in words what the unit rate means in this context of the problem, meaning what are you talking about? The last part says, is there more than one unit rate that can be calculated? How do you know? Well, don't get caught up on that question. Let's just try to solve for the unit rate one way and see if we can find a unit rate in another way, and then we can answer that question. Well, I'm just going to start with the given information. I have 1 1/3 square yards, or yards squared. Okay, so yards squared because we're talking about area. And then I'm going to write the area of the poster, which was 8/9 yards squared, or square yards. Okay, and this one up here again was, we'll do BB for blackboard. Okay, I'm going to take the blackboard and I'm going to divide it by the area of the poster. Okay, so as I do this, I'm going to find the unit rate. And it's going to be the unit rate, or how much bigger the area of the blackboard is to the poster. Okay, I just wrote my complex fraction in a standard form, 1 1/3 divided by 8/9. Let's change that to improper fraction here. 3 times 1 is 3, plus 1 is 4/3, divided by 8/9, which is fine. Okay, keep, change, flip, keep, change, flip. We have a lot of cross factors here, which is great. 4 divided by 4 is 1, 8 divided by 4 is 2, 9 and 3, 3 divided by 3 is 1, 9 divided by 3 is 3, equals 1 times 3 is 3, 1 times 2 is 2, simplify to 1 1/2. Oops, 1 1/2. I know that I'm solving for the blackboard because I put the blackboard information in the numerator. Usually we divide the y by the x, the dependent versus the independent, but here they didn't specify which one is which. So I divide it this way first. So my answer, 1 1/2, means that the blackboard area is 1 1/2 times the size of the poster's area. And that makes sense because if I go back to my original values, isn't 1 1/3 larger than 8/9? Yeah, so this is my unit rate for the blackboard. So I found the unit rate, and then I explained myself in the context of the question. That's one way. Now, we solved for the area of the blackboard, its unit rate. Can we now flip and find the area of the poster in relation to the area of the blackboard? The answer to that question is yes. So let's start doing that problem by setting up another complex fraction. Okay, here's my new complex fraction. This time I put the poster area in the numerator, 8/9, and then I put the blackboard area in the denominator, 1 1/3. Okay, I'm going to write this in an easier way, less complex way, 8/9 divided by 1 1/3. Keep 8/9 as is, drop down the division sign, 1 1/3 again changes to 4/3. Keep, change, flip. Keep 8/9, change to multiplication, flip 4/3 to 3/4. Okay, Same cross simplifying again as before, but this time we have 2/3. Well, that's because it's in relation to now the poster. The poster, or the poster's area, is 2/3 the size of the blackboard's area. Does that make sense? Well, yes, because the poster is smaller than the blackboard. Okay, poster is fitting on the blackboard. So that's why 2/3, it's not a full whole number, okay, because it's not equal. And the 2/3, it's 2/3 of the size. It's 2/3 of the size of the blackboard, which was 1 1/3. So to the answer the question above, is there more than one unit rate that can be calculated? How do you know? The answer is yes. And we proved to ourselves that it was able to happen because we just switched the poster and the blackboard when we did our division, and our explanation matches our work. Therefore, we are able to, if we switch it and we can explain ourselves and we use the right units next to our numbers, we can have more than one unit rate. Okay, the last question. A toy remote control Jeep is 12.5 inches wide, while an actual Jeep is pictured to be 18 3/4 feet wide. What is the value of the ratio, think about what that means, of the width of the remote controlled Jeep to the width of the actual Jeep? What's a ratio? A ratio is a comparison between two quantities. I can write it with the word to, with the colon, or in terms of a fraction. And here's just an example using some variables. A to B, A to B, A over B, which also means A to B. Okay, glad we have that. Well, now that we know what a ratio is, let's see what kind of ratio they want, because the order of a ratio matters. The width of the remote control. Well, what was the width of the remote control Jeep? 12.5 inches. To, what's the width of the actual Jeep? 18 3/4 feet. Can you write this in a different way? 12.5 colon 18 3/4 feet. Let me put my inches here. Okay, now, the way that we usually write our ratios is in fraction form. How would you write this? Think about what number you say first in the ratio. You read from left to right. So 12.5 is the first number, therefore 12.5 goes in the numerator. That's very important. Over 18 3/4 feet. If you got stuck at the beginning, then you may not have been able to answer the correct ratio. These are great ratios, but now we actually have to do the division and simplify. Okay, so this is the correct setup. If you want to try to do this division here now on your own, this would be a great time to pause the video again and see if you can do it on your own. Okay, so here's my complex fraction. 12.5 inches divided by 18 3/4 feet. Keep the units there. They're going to help you in the end. Then I took my complex fraction and wrote it normally so that I can carry out my division. Okay, you need to change both of these values to improper fractions. So 2 times 12 is 24, plus 1 is 25 over 2. Bring down your division symbol. 4 times 18, okay? Totally fine to do this work on the side of your page. 18 times 4, 4 times 8, okay, 32. 4 times 1 is 4, 5, 6, 7, 72, plus the 3, 75. 75 over original denominator of 4. How you doing? Hopefully you're doing well. Division means keep, change, flip. keep, change, flip. Thank goodness we have plenty to simplify here. 25 goes into 75 3 times. 2 goes into 4 twice. 1 times 2 is 2. 1 times 3 is 3. Okay, what is the ratio, the value of the ratio? Well, let's pause. Go back to this complex fraction. What does the numerator represent? It represents the inches and it represents the toy. Okay? The denominator, therefore, represents the actual car or the Jeep, and that's going to be in feet. Let me fix that. It's a little sloppy. Sorry. Feet, and that's the Jeep. Okay. You can write it in this format. I would definitely put the inches and the toy and the feet and the Jeep next to it. You can also write it as 2 inches to 3 feet, or 2 inches to 3 feet. Another acceptable answer, if you didn't like that we were working in 2 different units, you could think to yourself, how many inches are in 1 foot? And the answer to that is 12. So if you have 12 inches, how many are you going to have when you have 3 feet? 12 times 3, 36 inches. So another possible ratio besides these over here is you can have 2 inches to 36 inches. And if you wanted to simplify that, you could say to 1 inch, if I divide this by 2, divide this by 2, is 18 inches. These are all acceptable. I'm sure a lot of us had just this fraction up here, which is great. Just make sure you have your units. How did you do in your homework? I hope you did well. If not, just try to see where your mistakes are. And remember, I always have lunch labs on Tuesdays and Thursdays, so come and work with me. Okay, bye.